Let's all welcome Siemens Regional Technical Manager, Sean, as he discusses 10 things you should know about Solid Edge.
Good morning. My name is Sean, and it's great to see you here today. I know some of you are new to Solid Edge, and some of you are old friends, but may not have kept up with the latest developments. So before we get into the latest release, what I'm going to do is to spend this next session discussing some features you may have missed, and also other key areas which make Solid Edge so unique. So here are 10 things you should know about Solid Edge. As you can see, the list in the agenda covers everything from the most integral part of the software, how it works, right down to specialized features and connections with other domains. Let's get cracking. Number 1 on our list is Synchronous Technology. Synchronous Technology has been with Solid Edge for around 15 years now, and still nobody has been able to combine its modeling precision with ease of use. What is synchronous technology, some of you may ask? Well, for one, it's better than history-based modeling. Why? Well, there is no design pre-planning required because synchronous technology is history-free, which means that it doesn't matter which feature you create first. You will not get rebuild errors editing your parts. This means that you can design faster than ever without worry. There's also an inbuilt design intent, which reads your designs kind of like an artificial intelligence, which recognizes things like symmetry and tangency and places relationships accordingly. It's also fast and flexible and allows quick design changes. And this is courtesy of tools such as the steering wheel, 3D driving dimensions, and also 3D relationships, things which are missing in other software. Synchronous technology also allows you to easily reuse imported geometry because features are not required for editing in Solid Edge. You can make the required design changes very, very quickly without anything standing in your way. But not just that, synchronous technology is also better than direct modeling, which some other people may compare it to. Why? Because first of all, it is feature-based, so Solid Edge contains both functional and treatment features. What this means is that something like a hole is treated as a feature instead of just a collection of faces, which direct editing programs tend to do. When you click on a hole in Solid Edge to edit, it goes back to the hole menu where you can change the hole type, for example, from a simple hole to a counter bore or a countersunk hole. So you see there is intelligence built in. It is also highly automated. You can drive your models using parameters, and these parameters can then be connected by equations using sensors, which we will also get into later on. And neither are you stuck using synchronous. You have the freedom to switch between synchronous and ordered modes. So there is greater flexibility to work the way you want to work, not the way the system forces you to. Number 2 on our list is the learning page. Think of the learning page as a go-to area for all things Solid Edge related regarding learning materials. First of all, it is convenient. All learning resources are in one area, so there is no need to hunt around in multiple areas to learn Solid Edge. You even have the option of starting Solid Edge on the learning page. It is also specially curated, so you have a step-by-step access to picking up and learning Solid Edge. So this is great whether you are a beginner or experienced user. It is also very comprehensive. There's a wide range of materials for every level and also every domain, whether it's short tutorials or step-by-step instructions for specific commands. And finally, it's also customizable, so you can add or remove your favorite websites, whether they are Solid Edge related or not. And access is just a click away. Number 3, sheet metal. Solid Edge has long been regarded for its strong sheet metal functionality, and here are the reasons why. It sits in the most flexible design environment, so yes, that's synchronous technology again, which means that as you design sheet metal, you design it really quickly and make changes very quickly too. Have a look at how easy it is to create flanges and bends, adjust angles, and even make wholesale changes to the geometry. This speeds up your design time and adds a flexibility that you cannot find anywhere else. In addition, we have domain-specific commands for features like forming tools, such as dimples, beads, louvers, or embossers. This completely eliminates the laborious process of setting up, or even worse, editing library features, especially when changes are needed. Another great time saver. Next is something fairly recent, 2D nesting, which goes beyond just the creation of sheet metal parts and looks at optimizing the material that you need to manufacture these sheet metal parts. It automatically extracts the required data from Solid Edge. You can select multiple blank sheet sizes and then start the optimization process. 2D nesting makes use of the most efficient algorithms to generate the least wastage for the parts you are creating. It is smart enough to make use of the gaps and holes in large parts to fit other small parts in, further increasing sheet usage. This gives you a very quick and high return on investment, saving money for you and your business. Number 4 is advanced assembly features. And one of these is what I consider quite overlooked, which is virtual assembly design. It's really quite useful for designers creating mechanisms or even machines where placement needs to be done before you want to create your components. You start by creating a virtual product structure with assemblies which can be represented by sketches. So this then allows you to quickly work out how much space you need, or in a case like this mechanism, investigate different mechanism ideas. Once this is done, detailed part design can then be assigned to different team members, with the full confidence knowing that the final subassemblies will fit as planned. And publishing the virtual assembly creates real solid edge parts and assemblies in the very same placement, with your 3D model coming to life. Next is in assemblies is sensors. Now, you can think of sensors like a design spell check. It provides continuous feedback and easy capture and application of your design rules and criteria. You can define the following types of sensors: minimum distance sensors, general variable sensors, sheet metal sensors, surface area sensors, or even custom sensors. Sensors ensure design integrity, preventing unseen errors which might otherwise not be caught until it's too late in the production cycle. And finally, there is Goal Seek. So what Goal Seek aims to do is that it automatically iterates physical parameters to achieve a specific goal. Like, for example, in this uniform tank, non-uniform tank, where you are trying to limit the total mass to maybe 3,500 kilos, and the variable is the height of the fluid in the tank. Goal Seek will automatically adjust the height until the mass converges on that 3,500 kilograms. That takes the guesswork out of your problem. Number 5 on our list, engineering reference. Now, this one I really like because I remember when I was a young design engineer, and I had all these large engineering handbooks sitting at the table helping me to design to certain standards. With engineering reference, all the reference information and knowledge-based principles are embedded right within Solid Edge. As you can see, engineering reference allows you to design a wide range of components, from shafts to cams, gears, sprockets, and even springs. In this example, we're going to design a rack and pinion system. Engineering reference allows us to do this very, very easily with its wizard. All you need to do is input various parameters, such as pitch diameter, pressure angle, and material. There is an inbuilt verification system which automatically tests the parts for strength to tell you whether you can expect the components to pass or fail, and then you can adapt your parameters accordingly. When that is done, you just press Create, and engineering reference will automatically model your components. Can you imagine how much time this saves over manually creating these parts? Best of all, being able to visualize and test these components in the virtual environment means a reduced need for physical prototypes. Number 6, NX Nastran. As we know, simulation is made up of 3 broad steps: pre-processing, solving, and post-processing. And while pre-processing gives you options and post-processing displays nice pictures and graphs, what really determines the accuracy of your results is the middle portion, the solver, because these are the brains behind any simulation tool. NX Nastran, which stands for NASA Structural Analysis, was born out of the NASA space program and still forms the backbone of all our Siemens simulation solutions, from solid edge simulation all the way to our most advanced simulation tools. Over the years, it has been improved upon and has been proven countless times over in real use, from the moon to Mars and back here on Earth. Because there are some things with no margin of error, and it's good to have a solver you can trust. Number 7 is another recent development, and it's called Shape Search. Shape Search can be found in 2 solid edge tools. The first is where you might be looking for a particular component that you already have in your library, but you just don't know where to find it. Instead of using keywords, you can either open a geometrically similar model or actually create a model with a similar shape, and Shape Search will look and find these similar items. You can then open the result and compare these different models, selecting the one that you want. Ultimately, this allows you to avoid creating duplicate parts and results in big savings of both time and money. The second is 3D Find It by Cadenas, which gives you access to millions of manufacturer parts available on the 3D Find It website. Among the various search filters such as text, category, or size, you can actually draw out a shape, and the library will actually search for the components which fit the shape. That's a really intuitive way of finding parts. And when you find the part that you want, it is automatically inserted into the active assembly in Solid Edge. Simple as that. Number 8 on our list is data management. Now, data management is one of those areas that I personally feel is needed by every company, whether you're a one-man show or a large enterprise company. And having spoken with many of you, I'm sure you know the benefits of data management. However, I also know that many of you are hesitant to implement data management tools, mostly for 2 reasons. Number 1 is cost, the cost of both the software and setting up and implementing data management. And 2 is the difficulty and time spent in that implementation phase. Now, understanding that, we have decided to make Solid Edge data management free, which means that it's included in every license of Solid Edge. It will solve the most common data management headaches with tools such as fast search, revision control, where you can check in and check out your files, automatic part numbering, as well as lifecycle management, including a quick release workflow. It's extremely easy to set up with no separate database required. And if your company's needs outgrow the built-in capabilities, well, it's also fully scalable to Teamcenter. Once again, this is completely free and included in every license of Solid Edge. Number 9, the Solid Edge portfolio. By now, most of you would have known that Solid Edge is more than just mechanical CAD. We have a wide range of what we call pillars in different domains, where we offer a complete set of solutions that address the needs of a wide range of industries, from mechanical to electrical design, simulation, manufacturing, technical publications, data management, all the way to cloud collaboration. Each of these meet a specific need for specific companies. Plus, they work really well together, coming from the same family, with Solid Edge as a hub. Each is designed for ease of use, with minimal setup and a quick path to productivity. We also place a high emphasis on value, making sure that even small businesses will be able to take advantage of the breadth of capability. And finally, there's a peace of mind knowing that, coming from Siemens, there is a single source of support. And now we come to number 10 on our list, the Siemens Mechanical Design Bundle. We know that many of you have a wide range of design needs, from single component design to advanced machinery. And at the same time, you want all of this as high value as possible and as low cost as possible. This is why we have created the Siemens Mechanical Design Bundle, which combines both NX and Solid Edge into one license and allows you to use them interchangeably. Using disparate design systems can complicate your processes and drive up your costs. But with the Mechanical Design Bundle, interoperability is a given because both NX and Solid Edge sit on the same Parasolid kernel. This promotes collaboration and reduces your risk. You are also able to maximize the flexibility of this bundle by mixing and matching different software add-ons to meet your unique business needs. And finally, by simplifying the purchase and implementation processes, you reduce your total cost of ownership. So once again, these are the 10 things you should know about Solid Edge. I thank you for your time, and I hope you have taken away something useful in this session. I'll see you again in the next session.